Alright, in this video we're going to be working the AP Pre-Calculus practice exam, the multiple choice questions from the website. And I will say I taught AP Pre-Cal the first year it was offered, and I am not teaching it anymore, so I might be a little bit rusty with my pre-calculus, but I took a request for this exact exam, and so I thought it might be a good idea to record a video. We're going to get started with some no calculator. Do you remember that? It's like calculus. We start with no calculator. Polynomial p is given by this factored equation. What are all intervals on which p of x is greater than or equal to 0? Well, I'm going to think about the degree and the leading coefficient. I see three x's. It's going to be x to the 3 with a negative leading coefficient because of this, bit of negativity out there. So I'm thinking degree 3 leading coefficient negative. So the end behavior is it's going to come from above and go down. It is going to have three zeros because I can see if x equals 0, if x equals 4, or if x equals negative 2, the output of p is going to be 0. So I kind of know what that graph looks like. It's going to be, like that. And if you were, expecting to make a sign chart, that'll still work. You can totally do that. This is kind of equivalent, but if we know the end behavior and we know the shape of the graph and we know the zeros, we're going to be able to make this determination a little bit easier, in my opinion. Okay, so I'm seeing zeros at x equals negative 2, x equals 0, and x equals 4. And then we're interested in when p of x is greater than or equal to 0, so it's going to be up here and through there. So 0 to 4 and when x is less than 2, so that's right there. Okay, the next one is saying f of x is 9 times 25 to the x. Which of these is equivalent to f of x? Oh, okay, so I can say that 25 is, 5 to the 2. Okay, taken to the x power, and the question is, okay, what are we doing with these exponents? Okay, when we're taking power of a power, we're multiplying the exponents together, so it's going to be, what's the difference between, the multiplier in front. Yeah, I haven't done anything to the 9. If I wanted to deal with the fact that that was a square, I could say that that was, 3 squared times 5 to the 2x. And I guess, if a person really had to write this in a different form, you could say that was 3 times 5 to the x, exponent before multiplication by 3 squared. But that's not one of the answer choices, right? So it's going to be this one. Okay. Now, number 3. Yeah. Okay, I remember this. I feel like I've worked this problem set before, but maybe it was just that we used these questions throughout the year when I taught AP Pre-Cal, but I definitely remember this graph. When is f increasing and concave down? Okay, f increasing means that we're going uphill, and concave down is a kind of a sad attitude. So if I put those together, it would be something like that, increasing and concave down. And so that would be a to b, and then we don't resume increasing again until after D, but then it's increasing and concave up because the graph is smiling. All right, so just A to B. Okay, which the following describes the end behavior of f. Okay, so again, we've got degree 6, leading coefficient is positive 5. So that means that it's going to look a lot like positive x squared. Okay? So that was pretty shaky. So let's say it's going to look, at least on its outsides like that, this, there might be some wiggliness and back and forth in the middle of that, but either way, as x approaches infinity and negative infinity, f is going to approach positive infinity. To let x and y be positive constants, and we're going to do some log properties. Okay, so I think the first thing I'm seeing is the subtraction. And so I'm going to say that the log of a minus the log of b, that's equal to the log of a divided by b. And when I say log, I do mean natural log. Then we've also got these multipliers here, which I think I am going to have to deal with that first. So this... multiplier p times ln x, that's going to be the same as the log of x raised to the power. And so I'm going to say, I guess first, this is going to equal log of x squared minus log of y cubed, applying the power property. And then I would apply the quotient property and see log of x squared over y cubed, and I can go look for that. There we go. Right, number 6. The polynomial p is given by x to the 3 times x squared minus 2x minus 15. Okay, before I even keep reading, I know I can factor that, and I know that's kind of how this class works. It's a lot of factoring, so I'm going to factor it. This is x minus 5, x plus 3. Okay. So that's the same as x plus 3 squared times x minus 5. Which of these describes the zeros of p? Okay, so I'm going to have a 0 at x equals 5, and I'm going to have a double root at x equals negative 3, which means... Okay, and talking about non-real zeros, okay, that gives me pause. Kind of forgotten that was a thing in AP Pre-Calc, because we just don't deal in non-real numbers at all in calculus. But I'm thinking, just to be like, oh, what if I was just thinking, what if I made a factoring error? I'm going to look at b squared minus 4ac. Okay, yeah, and that would be 4 minus 4 times 1 times negative 15. And I know that's going to be a positive number because of the negative negative. Okay, so that's greater than 0. So get those non-real zeros out of there. 2 distinct real zeros. One of them's a double root. It's going to make the graph look like... it's kind of sloppy, but that's negative 3. That's 5. Let's keep going. All right, in the xy plane, the graph of rational function f has a vertical asymptote at x equals negative 5. Which of these could be f? Okay, well, not a, because if I can cancel them out, that's going to cause a hole in the graph. Wait. Okay, x equals negative 5. Okay, so that means there's a hole at x equals 5, but in order to have a vertical asymptote at x equals negative 5, we need to still be dividing by 0 at x equals negative 5, so that one's no. That one doesn't have any vertical asymptotes. This one has a vertical asymptote, but at x equals 1, and the hole would be at x equals negative 5. This C has vertical asymptotes at x equals 5 and x equals negative 2, but that's not what we're asking for. This is the one, okay, because of that and a lack of a canceling factor in the numerator. I'm going to see a vertical asymptote, yeah, because the division by 0. That is the cause of vertical asymptote always, at its core, division by 0. So let f be a sinusoidal function. The graph of y equals f of x is given in the xy plane. What is the period of f? So we're going to measure that one top to top, 1 to 5, that's 4. Ooh, I liked that problem. Yeah, that one was good. Okay, transformed graph, f of x plus 1 minus 2. So I'm going to go left 1 and down 2. Okay, so I'm going to just kind of try to follow that point right there, the bottom of the circle. And so if I go left 1 and down 2, I should be at 1 and negative 4. There it is. I think that was A. Yeah. Yep. All right. A times b to the x, a and b are positive constants. The table gives values of f. Which of these statements is true? Okay, I'm gonna have to say that it's exponential growth. The f is getting bigger. Okay, so it's definitely not exponential decay. As x increases, f of x is also increasing. That would be exponential growth. Now, a is the value of f of 0. You've probably seen that when you were studying exponential functions in this class. That would be a times b to the 0, and b to the 0 is going to be 1, so that's just a. Right? And so a is 3/4, so a is positive. Okay, well, I probably should have looked at the answer choices first because I could have known that from the answer choices. B is between 0 and 1. No, the number I keep multiplying by is 2. I keep doubling 3/4 to 3/2 to 3 to 6 to 12. B is bigger than 1. 2 is the doubling factors. number that's taken to the x power. It's that factor we keep multiplying by over and over again. That's kind of the hallmark of the exponential function. All right, and x squared plus 1, x minus 3 over x, f of g of x. Oh, I always like these. So really what I'm going to do is wherever I see x in the formula for f, I'm going to replace it with g of x. So f of g of x, that's going to equal g of x squared plus 1. Okay. And then I'm going to want to square the x minus 3 over x. Oh, this is going to involve some algebra. And I might just write it out as actually, squaring it. Just make sure I don't make an error. Okay, in the denominator, that's definitely going to be x squared because multiplying fractions. I'm just going to multiply straight across. So I've got x squared, and when I multiply the numerators, I'm going to say, all right, x squared minus 3x minus another 3x, and then plus 9 over x squared plus 1. Wait, that's answer choice C. Huh. I really thought that they were going to make me combine this with a common denominator, and I was going to have to turn the 1 into an x squared over x squared, and I was going to be looking for 2x squared minus 6x plus 9. Okay, but they were pretty generous on you here. If you're in my pre-calculus class, we definitely would have taken that all the way to a single fraction. But, that's answer choice C, we're ready to go. So, which of the following claim and explanation statements best fits these data? Well, I'm just going to have to look at the difference. From 53 to 78, that's 25. Then 78 to 97. Let me think about this. 78, 88, 98. Okay, so that's 19. 97 to 110. Well, 3 would be 100, so that's 13 and 7. All right, and then the second order difference is going to be -6. -6 and -6. So that means we're going to have a quadratic function, so we've got a constant second order difference. Well, I can't help but think, feel bad for anybody who's like learning English and trying to solve this problem. Okay, I'm down to quadratic, so I'm just ignore those two options. Really the difference, because the rate of change. Oh no, okay, it's very subtle with wording. This is. Oh yeah, no, this was one thing I suggested the students in my class do. Just take out stuff, especially the stuff that comes right before the verb, which is in this case. The rate of change is not constant. That's what they're saying. They're saying the rate of change is constant, and it's not. It's the rate of change of the rate of change, which is constant. The change in average rates of change over consecutive, yeah. I always thought that was funny. All of this rate of change and calculus discussion in the pre-calculus class, but I really enjoyed the discussions that we had about the graphs and the concavities and the rates of change when I was teaching the class, and I do remember that. Okay, so which of these is an equivalent form for g of x? Oh, double angle formula. This is one I do know. I'm not the best with trig identities, but I can usually figure them out from the ones I do know. Sine of 2x is 2 sine x cosine x. So if I was going to take that and multiply it by 7, I would need to do that on both sides. And so that would be 14 sine x cosine x. All right. each time the input values double, the output values increase by 1. So if I go from 2 to 4, this one just caught my eye, and 4 to 6, I'm going up by 1. Wait, no. I can go up by 1 when I went 4 to 6, but that wouldn't be what I want anyway. I want to go up by 1 when I go 4 to 8, and I did, sure enough. Okay, when input values double, that's the x values double, output values increase by 1. Okay. That could be a graph that fits that description. Without any sort of consideration for what type of graph it is, just thinking about the description I was given. Complex number is represented by a point in the complex plane. I forgot this was part of AP Precal. Complex number has the rectangular coordinates 3 and 3. And so I'm probably going to need to draw a diagram. All right, and so 3 and 3 looks to me like it would be about there. So what I think it would probably be good to do is draw the right triangle. Okay, so that means this leg is 3, that leg is 3. Okay, we're interested in r and theta. R is distance from the origin. So 3 squared plus 3 squared equals r squared. Okay. And, you could add right now and say r squared equals 18 and then simplify the radical. But what you could do is say that this is 9 plus 9 is 9 times 2. And then when we take the square root of both sides, okay, we're interested in the positive value of r because it's like looking at r cosine theta plus I times r sine theta. X equals r cosine theta, y equals r sine theta. Really my job here is to find r because if you're in AP Precal, you should be able to know what the value of theta is just from looking at the diagram. And knowing that each of the legs are equal in length. R is going to be the square root of 9 times 2, which is the square root of 9 times the square root of 2. So that can make your life a little bit easier. And that's going to help me eliminate down to A and D. What's the deal here? That is not negative pi over 4. This is positive pi over 4 as theta. So it's x equals r cosine theta and y equals r sine theta. And yeah, because this is the complex plane, this is the set of real numbers, and this is the set of imaginary numbers, but you actually don't need to know that to solve this problem. If you know that x is r cosine theta and y is r sine theta, I don't know what's going on here with the yellowness behind the blue writing, but I'm just going to hopefully move on. Using some new software I've been recording lately because I had some serious technical difficulties I just couldn't solve. Not the best with computers, but also not the worst. But I did figure out this solution in some slightly different software to duplicate my tablet, and it seems to be working okay. Okay. Pardon me, got a phone call. Lost track of where I was. Okay, so this is the classic circle ray diagram. Really what makes AP Precal, to my memory at least. I really liked this view of trigonometry. Okay, standard position, terminal rays. Okay, this is all seeming great. Sine of theta is going to be y over 5. Why? I don't know why it would be negative y over 5. It's the vertical displacement of p from the x-axis to the distance between the origin and p. Yeah, that's d. You can't actually see that, but presumably you've been working this on your own. You've got a copy of it nearby. Okay, that was interesting. Very difficult question. If you know about sine and cosine, which I have to think if you've made it through the whole year of AP Precal and you're reviewing for the AP exam, you're going to know what sine is. So now we've got f of x is 3x squared plus 2x plus 1. Image of the graph of f after a vertical dilation by a factor of 2. Okay, vertical, all of that stuff happens on the outside. So vertical dilation by a factor of 2 is going to be going from f of x to 2 times f of x. And, just to emphasize that multiplication, I'm going to put f of x in parentheses. So I'm going to say that's 2 times 3x squared plus 2x plus 1. And that's going to be 6x squared, 4x, and 2. That was generous. I'd have had 6x squared plus 2x plus 1 as an answer choice. Okay, so 6x squared plus 4x plus 2. I don't actually need to read the rest of the writing, right? Because that's the only one that actually has, k of x, or the correct polynomial. Yeah, we multiplied f by 2. Yeah, that's totally what we did. Functions f and g are in the table. H is f of g of x. H of 0, that's going to be f of g of 0. You just write it out. Go find g of 0. It's there. That's 1. Okay, and that's going to be f of 1, which is negative 2. Right. F and g are defined for all real numbers such that g of x is f of 2 times x minus 4. So the following sequences of transformations. All right, so we got to start from the inside and work our way out. Wait. Yeah, because they don't commute. Okay, I think what I'm going to do is just get a hypothesis, because I know, okay, if I multiply by 2 on the inside, the horizontal translations work the opposite of the way you expect. So it's going to be a horizontal dilation by half. So again, getting rid of a and b. And then a horizontal translation of 4 units to the right. So, well, I guess that really doesn't leave me, because negative 4 units would be going to the left. I know x minus 4 goes right, so translation by 4 units, positively, that's going to the right. Okay, so I didn't actually have to worry about the sequence, because that's the thing. It's like, did I actually, I think what I did is if I go from f of x, I have to map it out, to f of 2x, and then we replace x with with x minus 4 in parentheses. That's actually how we get that expression. If we'd gone the opposite order, we'd actually have had to gone right 8 units and then horizontally dilated by a factor of half. Okay, so we didn't actually have to make that call. So which of these could be an expression for f? Okay, well, I think the first thing I want to do is find the midline, like what's halfway in between the maximum and the minimum. It goes from 2 to negative 4, and it really just, to me, I'm seeing these spots right here that look like they're halfway in the middle. Yeah, it's negative 1. Okay, but that did not help. I should have peeked at the answer choices. Okay, looks like all we really are doing is seeing, all right, it's kind of like the starting value is this translation. Let's say, I'm going to just focus on this point. That's pi over 4. And it looks like, the graph is coming up through pi over 4, and it's at the midline. That's kind of like the graph of y equals sine x at the origin. So I think this is just like a translation of positive sine x by pi over 4, yeah. Sure, what would lead me to believe that was pi over 8. But it's okay. Oh, I guess because of the 2. Just thinking about that. No, shifting right by pi over 4. Then I'm... Ooh. Wait a second. Yeah, I think it is going to be B. I'm going to think about this for a minute. That's funny. I was just saying the previous problem was one where I didn't have to make the decision about the order of the transforms, but I should have known better than to think I was just going to get out of this problem set without having to think about that at all. Okay, so if we start by, really what we should think about doing is crunching the graph first, so then we can just move it around however we feel. So that minus 1 is the way we expect, the translation is how we expect. So if I think about it the way I just was, we go from f of x to f of 2x, or some function to function of 2x, then shift right by pi over 4 and have that. But b would not, okay, yeah, b is not going to work. It is c after all. I just needed to talk myself into it. Okay, and to me, that's the trickiest thing in an Algebra 2 class or an AP, or in a pre-calc class, is the transformation of functions, and specifically the non-commutative ones where the order does matter. It's a very touchy subject. So let f be a rational function graphed in the xy plane. This is a much less touchy subject. Consider x equals 1 and x equals 7. Okay, I can do that. The polynomial in the numerator of f has both a 0 at x equals 1. Has a 0 at 1. Doesn't have a 0 at x equals 7. Okay. Okay, the denominator has zeros at both. Okay, so this is a very simple version of f, but this could be believable. The multiplicities of the zeros at x equals 1 in the numerator and the denominator are equal, so that means there's going to be actually a hole there. And so there's going to be a hole at x equals 1 and a vertical asymptote at x equals 7 because, we're still divided by 0 after all cancellations. So, yeah, there we go. Right, now, the increasing function p gives the number of followers in thousands for a new musical group on a social media site. Okay. Yeah, I guess that's the difference between AP Pre-Cal and AP Calculus. AP Calculus, we're still using the multiple choice problems where it's like the number of CDs sold over a 12-month period. I just got that one recently and just really spoke to me this year. Okay, which of the best models applies? So I guess really what we're trying to figure out is it linear or is it exponential? So are we adding the same number each time t increases by this constant amount of 1, or are we multiplying? 2 to 3, that's multiplying by 1.5. 3 to 4.5, same story. Yeah, we're multiplying by 1.5 each time. So that's the only one that has multiplying by 1.5 each time. 3 halves to the t. 3 halves, that's 1.5. Okay, if we were, sure why we would think 325 over 16t plus 20, I bet that's like what we would get if we just took the equation between the 2 points at the edges. Okay. Polynomial k has k of x equals ax to the 4 minus bx to the 3 plus 15. A and b are non-zero and real. Each of the zeros of k has multiplicity 1. An x-intercept is 17.997. Okay, so I know that I've got one real zero and a complex root, which means that I've also got another complex root because they come in conjugate pairs, plus 0.801i. Okay, so that's 3. I couldn't have the fourth being a also complex because, or like non-real, because it would need a friend. Okay, so I know that I've got 2 real roots, meaning 2 x-intercepts. Okay, must be true 3 x-intercepts. No, this is a degree 4 polynomial, so it's got 4 zeros, 2 of which are already taken up for non-real complex. So that one's going to have to be true. For real solutions, no, I already know one of them's not real, and then graph of k is tangent to the x-axis. Okay, just in case that doesn't come up again, what that means is, if this is my x-axis, it's helpful to them. Y'all would call it like a bounce or something, like where we go. That's tangent to the x-axis right there. That's the type of situation we have when we have a, double root, quadruple root, some kind of root with even multiplicity. Right, log base 10 of x plus 1 plus log base 10 of x plus 3, and g is some other function. All x coordinates the points of intersection on the graphs of f and g. So I think what I'm going to do is I'm going to combine the logs on f. X plus 1 times x plus 3, because that's the relevant log property, log of a plus log of b equals log of a times b, and that works even if it's not a natural log. I struggle to understand why anyone would use a non-natural log, but we got all types in AP Pre-Cal. So x squared plus 2x minus 3, doing a little bit of FOIL, and I need that to equal log base 10 of x plus 9, so I'm just going to set the two things equal to each other, or maybe take 10 to both sides power is really what I'm doing. I can even show myself doing that. 10 to the log base 10 is just gonna kill off the exponent, because the log base 10 is the special exponent I put on 10 to get whatever is the argument. Okay, so if I'm thinking about, taking 10 to the power of the special power I take on 10 to get x plus 9, I'm gonna get x plus 9. Okay, so x squared plus 2x minus 3 is equal to x plus 9. Let's subtract, set this thing equal to 0. That's how we solve an equation with more than one power of x in it in the same equation. Okay, I've got the x squared, I've got the x. I'm going to have to set it equal to 0 and factor, possibly use quadratic formula, use technology, hope for the best, but I will never be able to directly solve an equation that has multiple powers of x in it. So I'm going to factor, I can see 4 and 3, so I'm thinking plus 4 minus 3. Okay, but I need to be careful and make sure, yeah, x equals negative 4. You would think that would work based on the algebra here, but this right here would not be defined if x was negative 4, because I'm trying to take the log of negative 5. So that one's extraneous, you're out, and x equals 3 only. Right. And then the next one, values of theta, 0 to 2 pi. Okay, so we're going to have to solve this trig equation. Now you could divide both sides by sine theta, but I would not recommend doing that because you have to think about, oh, what if sine theta is equal to 0? And if you look at it, that's actually going to be a solution. You're better off setting this thing equal to 0 and solving. Okay, and I don't know how you do this. If you see the factoring, go ahead and just factor it, right? But if you don't, and you know you're supposed to solve these trig equations by, doing some sort of factoring, if you don't have to do a trig identity, and I would not recommend doing trig identity here because I don't think it would help, I'm going to just use a different letter, like let t equals sine theta. Then I'm just going to do the algebra in t for a second. So 2t squared plus t equals 0. I can factor out a t from both of those expressions. Now this is very familiar. If these two things multiply to equal 0, one of them has to equal 0. And this would happen when t was negative a half. And so, but that's not my answers. Fortunately, they didn't leave those as theta values. That's like a bad answer choice. But I'm just going to say, all right, sine theta equals 0 from that part of the solution. Or sine theta equals negative 1/2 from this part of the solution. And so I've got it down to trig function theta equals number. I'm just going to be kind of thinking about the unit circle and thinking about, okay, first of all, where's sine theta equal to 0? That's going to be right here and right there. When's the vertical distance from the x-axis going to be 0? And so that's going to be between 0 and 2 pi. That's 0 and pi. Okay, so I like A and B, I'm not liking C and D. Okay, and then I'm going to think about sine of x equals negative half. Now, on the unit circle, negative half's not very far, because, again, I don't know how you do your trigonometry, but 0 less than a half, less than root 2 over 2, less than root 3 over 2, and the biggest we can be is 1. So I draw it like kind of exaggerated, so negative a half would be just really not very far down on the unit circle, and so it'd be like kind of just the next stops on the unit circle. So this is going to be pi over 6, because that's the smallest, kind of theta distance we've got. Pi over 6 greater than pi. Okay, pi is 6 pi over 6. I've got 7 pi over 6. I think that should probably do it. Yeah, okay, so I've got this one right here. Hey, and the fourth 0, that is indeed 11 pi over 6, but I'm satisfied based on the other three values. Okay, it looks like we've got a polar graph. Okay, we've got r equals f of theta. Got some points labeled. Okay, if f is restricted 0 to pi over 2. Yeah, that's a great question. Okay, what we need to do is sketch the graph of f rectangularly. That's the secret on this one. Okay, for cosine of 2 theta, we know positive cosine, if we're just going to use the window pane technique, it starts positive, and then we just kind of like draw our graph. And if you've never seen that before, you can just check out my AP Pre-Cal playlist and graphing rapid trig functions or whatever. Really nice technique, not one I invented, one somebody showed me. And then it's just 4 cosine of 2 theta. Now, okay, so the multiplier being 4, I don't think that's so important. I think it's going to be the horizontal axis, the theta axis, that's more important. So this, since I don't have any vertical translation, that is going to be my theta axis. And then, again, no horizontal translation, that means this is going to be like y. then 4 cosine 2 theta. Okay, so normally I'd have 0 to 2 pi, but 2 theta is going to speed that up by a factor of 2. So this is going to go 0 to pi. So halfway there would be pi over 2. So really what they're talking about, if we're restricting to 0 to pi over 2, that's this section of graph. Okay, so r is starting off positive. Okay, so it means we're starting off here. It's going 0 and then negative. Okay, so let's point at where r went 0. Okay, so that means we were traveling along this section of graph, C to E. Okay, that's what they said. And then afterwards, it's just going to go negative until pi over 2 when r is -4. Okay, so pi over 2 and -4, I'll put a box around that. I would expect to be going up towards point B, but I'm going to go backwards 4 units. So that's going to be this point right here. And these graphs are pretty smooth, so it's going to be this portion right here. Also, yeah, between pi over 6 and pi over 2, that's kind of, it's going to be a little tough for me to 2, 3, 4, 5, 6. Okay, yeah, so yeah, pi over 4 to pi over 2. I don't know why I was freezing up on that. Okay, the space that's like negative r in those theta values would be just like kind of behind that. So that's why I know it's the stuff in the third quadrant, not the stuff in the fourth quadrant. I don't have to appeal to the, the smoothness of polar graphs or whatever. That's kind of beyond what we do in pre-cal. So it's going to be in quadrant 3 from E to D. There we go. Oh, yes, I remember this graphic. This is good art. Physical therapy center has a bicycle patient used for exercise. Okay, so really what we need to do is just think about, all right, the amplitude is going to be 8 because the arm, I can go either all the way up or I can go all the way down. And so it should be, 8 sine t or 8 cosine t. And 12 is the midline, so it should be like adding on the outside. So I've definitely got, A and C eliminated. Okay, now the difference is just going to be what's the period, because it's either sine t or sine of 2 pi t. A patient pedals 1 revolution per second. And what I remember from when I taught the course was period is equal to 2 pi over b, where b is that multiplier against t. So the period, 1 revolution per second is 1 second per revolution. And remember, period is how long it takes to do, 1 cycle. So that, unfortunately, we didn't have to worry because it was a 1. But that's going to be 2 pi over b, and multiply both sides by b, and I see b as 2 pi. All right, so that's going to mean d there. Yeah, I just kind of feel also obligated to say I was thinking about it in the moment and I just went with the actual formula because I was trying to be, giving a good example of how to solve this problem. But I do have to also point out that the period of sine t is 2 pi. You know that. And since the period of this graph is clearly not 2 pi, you could use process of elimination to go down to d and not actually worry about that. That would be valid. So on 28, got to be getting close to the end of this. I think you get an hour for multiple choice, no calculator though. Maybe 55 minutes or something in pre-cal. I know it says at the top. 1 plus 2 sine theta in the polar coordinate system. True about the distance between the point with polar coordinates theta, and the origin. Oh, is the distance increasing or is the distance decreasing? And so again, in order to do that, we need to draw the rectangular graph. Okay, so 1 plus 2 sine theta. Sine starts the middle and goes up. So it's like that. And we know horizontal translation and vertical translation of 1. The amplitude's 2. Okay, so that means I'm seeing that the horizontal axis is going to go through there. It looks about right. And so that would be theta, no vertical translation, so that's going to be my r-axis. And so the distance is going to be 2 sine theta, no change to the period. I should probably label that pi, 2 pi, half of pi, I guess that would be 1.5 pi. Okay, and if you wanted to, we could just get rid of that and have a good graph, but I was kind of using that for part of my vertical axis. Increasing 0 to pi over 2, because f is positive and increasing. Yeah, that is true. And I'm thankful that that's true because I don't have to read the rest of them. Decreasing for 3 pi over 2 to 12 pi over 6. E looks true, but r is negative and increasing. It's getting closer to 0. Okay, remember, decreasing is becoming more negative, becoming lesser, not going closer to 0. Oh, and that was the end. Okay, I didn't realize it was 28 questions. That's how AP Calculus used to be, but we're on to 30 questions. Is it 28 and like 55 or something? How does the timing work on this? It's pretty 1 hour, 20 minutes? Whew. It's 80 minutes and I'm sitting here at 40, and I feel like I really took my time and explained myself. Okay, so if you're taking AP Pre-Cal, you might be sitting around a while after multiple choice, no calculator. Okay, now part B, no laws of calculator. 40 minutes for 12 questions. Okay. Yeah, I'm just going to warn you, if you're taking AP Calculus next year, we have 2 minutes per multiple choice question on no calculator and 3 minutes per multiple choice question with a calculator. So you do have significantly less time to make those decisions in the calculus class. Oh, I remember this problem. This is a great one. Swimming pool is filled with water. Pump is used to remove water from the pool until the pool is empty. I thought this would have been a better problem if they said like somebody stabbed the side of the pool and it burst. You've seen the videos. When the pump is running, the rate at which the volume of the water in the pool decreases is constant. During the first 2 hours, the pump works slower than usual due to a broken piece. Then it stops working altogether. Okay, so slow, then stops working. And then after the piece is repaired, it goes faster. So I should be getting steeper. Okay. The entire process took 6 hours. Okay, so get rid of A. Yeah, that's okay. That's the only one that didn't take 6 hours. But I need to go shallower and then steeper. I think I see C, those line segments are parallel, so that one's out. I see no change in the effectiveness of the pump. So I guess the difference is when did it stop working? It stopped working after 2 hours, so that would be, I'd start going flat at 2 hours and then I'd resume at some other point. Okay, so I used all the information. I'm ready to go. Okay, this one looks like we are going to need a calculator. Okay, now we will be using Desmos because, in my opinion, if you are using a handheld graphing calculator and you have the ability to use Desmos on this, you are just selling yourself short. In fact, I'm going to show you one great application of Desmos right now. They're saying this is geometric. Okay, you need to know in AP Pre-Calc, geometric is the same as exponential. And I'm going to just do a quick exponential regression. So, and a 49,000. Okay, now I'm going to say I am not certain. Now, like right now, like you see this button right here, add regression, exponential regression. Okay, great. What's the population colony in day 6? I'm going to say, can I think I can copy this and paste it in as f of x. Yeah, that's great. And now I'm going to say f of 6, and I'm going to get 14,000. That's really, really nice, and that would take so much longer with a handheld graphing calculator to run that regression. Now you can solve this one without a calculator. You can figure out a and b, a times b to the x, that's an exponential function. You can figure out it as a sequence also, but I like the regression technique a lot. Okay, I will say that button where I had, like up here where I clicked and it said bring me a regression, I know for a fact that that was not available this year on our state test for Algebra 1. because we use a, a kind of a diminished Desmos for that test, I somehow tend to think you will have that regression option for you in AP Pre-Cal. And if not this year, definitely anytime in the future. If this video is, more than a few days old, I'd like to think that you'll have that regression capability, and that's really, really nice. So I'm just throwing that out there. Okay, that's one way we can use the calculator on AP Pre-Cal to really, really help us, especially if we're using Desmos. Now, the rate of people entering a subway car on a particular day. Okay, they're going to give me a function. I should probably graph it. Okay, because I'm seeing those 3 decimal numbers. That is a sure sign I should be using Desmos. 3t cubed, and you can write TTT, minus 0.846 t squared plus 6.587. I never understood why they would give me decimal coefficients. Just a lot of typing. 1.428, maybe just to emphasize the 3 decimals thing. It's like, I really wonder about people that are rounding to not 3 decimals on the free response after the multiple choice answer choices are all rounded to 3 decimals. Just remember, always 3 decimals in AP Pre-Cal, and it's the same in AP Calculus. Okay, so I've got a graph. Okay, it's not very visible. Okay, now I can see what's going on. It's a nice 3rd degree polynomial, kind of doing its thing. Based on the model, at what value of t does the rate of people entering the subway car change from increasing to decreasing? I just graphed the rate. This is a rate graph, which, again, I have my own opinions about that in a pre-calculus class, but they're asking when the rate goes from increasing to decreasing. I've got a graph of the rate. I'm looking for that spot right there, 5.505. So I'm going to select that answer and move on with my life. Now I've got the semi-log plot. And I will admit, this is the one topic I kind of like reviewed before making this video, because it's like, oh man, I remember that was in the class, and I don't even remember learning about this. I'm sure I did somewhere along the way, but it was very unfamiliar to me. But this is really just like plotting points. So vertical axis is logarithmically scaled. Okay, I'm going from 30 to 231. So I definitely don't need to be... Oh wait, and A is not actually logarithmically scaled. It just kind of, they did the shading or the relative weights as if it was. What is going on here? I do not want Google to recognize my voice. Pardon me, that's an unexpected and unwelcome interlude. I don't really mind Google recognizing my voice. It's not right now. Okay, this one's not logarithmically scaled either, and I am getting output values of m of t that are much greater than 10, so I'm going to eliminate that one as well. This one was pretty easy. Oh, whoops, you couldn't even see the bottom one because I still had the calculator going, but notice that it's not actually logarithmically scaled on A and D. We just had the kind of the weights of the lines were the same as they would be on a semi-log plot. That was interesting trick. All right, so at a coastal city, the height of the tide in feet is modeled by the function h given by h of t is this. I should probably type this into the calculator. H of t equals 6.3 cosine of pi over 6t plus 7.5. Okay, and for 0 to 12. And I am actually going to restrict the domain because that's something I found is particularly useful in calculus. 0 less than or equal to, and you just press the less than key and then the equal key, and it knows less than or equal to t less than or equal to 12. Okay, so now it's only going to show me what's going on 0 to 12 with this tide. Okay, and the maximum height of the tide is 13.8 feet. It does seem true. The maximum height of the tide occurs at t equals 6 hours. No, that's the minimum height of the tide. The minimum height of the tide is 1 foot. No, the minimum height of the tide is 1.2 feet. And the minimum height of the tide occurs at t equals 12 hours. No, that's not true. It's 6 hours. Okay, so the maximum height of the tide is, in fact, 13.8. Yeah, no, I could have done that without a calculator if we wanted to. But since we've got it available to us, we might as well use it. All right, we've got a transformed sine function. 2, 2, and 4, 4 are a minimum and a maximum. I mean, hate to be rude, but I disagree with the question. This should say which of these could be the values of A and D. Nope, actually, no. That this one, no. I was thinking about B and C. Oh, okay. This one's really not gonna be that hard. Okay, so we just really need to think about. I'm just gonna assume that that's the y-axis. So the maximum's 4, the minimum's 2. Means the midline's 3. Okay, D is gonna be the midline. So there we go. And then the amplitude is the distance up or down. That's going to be 1. Okay, I just need to read the answer choices. Values of A and D, those do have to be. Okay, but, I was thinking like, well, what if we had a bunch of waves? I was thinking that, can't necessarily assume they're consecutive minimum and maximum values, but we don't have to. There could be any number of waves in between those 2 points, and that will not change the amplitude in the midline. Okay, so S is given by this here function. But I will also say, this is in the calculator section, and I've got to think with Desmos, we might not be asking this question this way anymore. But I'm going to put table 2, 2, and 4, 4. I'm going to do a sinusoidal regression. And it's going to tell me that, oh, interesting. Why? Oh, I think you need a third point to run a really good sinusoidal regression. But I will say, you look at the given midline and amplitude, and the closest thing you've got is the right answer. So I'm just say that. But okay, that's enough. I'll go over here. S of t is going to equal. And remember, we can kind of use whatever letters we want, like as we're given them, except for x as an output. We cannot do that on Desmos. Like x of t, if you ever get the position of an object moving along the x-axis at time t is given by x of t equals this. I know that happens every once in a while in AP Precal. You can't use x in Desmos, and I could see that happening. X is a dependent variable. It's going to think that x is always the horizontal axis. Okay, so S of t is 500,000. It's also not going to like it if you type in the comma there. 1 plus 0.4 e to the kt, where k is a constant. Okay, if S of 4 equals 300,000, I'm trying to think how I would use the calculator. I gotta think that, okay, I gotta think there's some sort of way. Okay, if you want to do it this the entirely calculator way, you're going to plot the 0.4 and 300,000. You would have to go in and change the window up and let k on the slider go up to like between 175,000 and 360,000 and kind of move the slider. I want to do it a little bit more mathematically. S of 4 equals 3,000 or 300,000. So 300,000 is equal to 500,000 divided by 1 plus 0.4 e to the k times 4, because t is 4. Okay. And so what I might do is, in order to actually solve that, I might just go over here and say 4t graph y equals 300,000 and see where they intersect. We're going to really need to be zooming out. Yeah, there we go. It needs to be logarithmically scaled. Oh, well, 500,000, 400,000, 300,000. Where's my graph? That is 30,000. Okay, I had enough. I'm going to add a 0 in there. And okay, here we go. And I see them intersecting at, okay, the t value is going to be actually k in this case. Pardon me, I know that's probably confusing. But the thing I'm looking for is 0.12771. I can just go ahead and save that, delete all the rest of this stuff, and just call that k. Now I'm going to go in and rename this to be e to the kt, and then I can find S of 12 and get 175, 319. Okay, what? Off by 6. That's a little concerning. See, must be because of the size of the numbers. Or there's totally something I'm missing with this. Okay, well, I'm gonna just work it again, but I'll probably just work with the video pause. Okay, I don't know what's going on. I mean, I thought maybe if I simplified by dividing both sides of the equation by 100,000, graphing this, it would go a little better. Maybe I needed to be able to round or to have more decimals of precision in my value of k here, but I even like typed it in myself. I'm getting the 175,000. I think this is close enough that I might not be satisfied. Two function models K and M are constructed to represent the sales of product of a group of grocery stores. Product in thousands of units. Okay. So when will the logarithmic model, which is K, will be 0.1 more than the linear model? And so that's the equation I'm trying to solve. And so I'm going to just kind of clear out everything and say, right, 14 minus 2.885 log of t, y equals 14 minus t. But I actually want m of t plus 0.1 to equal k of t. And the first time, I see 2 times that happening. So that's 1.807. What is going on? First time t, sales predicted. Negative t plus 14. For t weeks, for t greater than or equal to 2. Okay. 4.324. There we go. I should have read that and said, okay, when t greater than or equal to 2, then I would not have even, been seeing that appealing wrong answer. I really did that one to myself. There we go. Now, the function f is given by f of x is 2 sine of 4x plus cosine of 2x using the period of f, which is following is the number of complete cycles of the graph of f, 0 to 1,000. This calculator, I should probably... I'm gonna go back home. And from top to top is like, okay, I'm just gonna call them kind of A and B. And find b minus a. And okay, the period's pi. I know that number. And so on the interval 0 to 1,000, I'm just going to figure out how many times do I have with pi and 1,000. It's going to be 318. Okay, there we go. And yeah, we don't have to worry about it all that much because there's all, so many different, there's so much difference in the answer choices. It's not like that. 319 and 317. Think about the incomplete cycles or whatever. So the graph of the piecewise linear function f is shown in the figure. Let g be the inverse function for f. That's the maximum value of g. Okay, so g takes in, so f is f of x, f takes in x's and gives back y's, and g is going to take in y's and give back x's. So the maximum value of g, like output values, is the biggest x I can see, and that would be right there at 5. Okay, 7 is the maximum possible input for g, because g takes in y values. All right, now function f is given by this formula. We have another formula for g. What are the zeros of g? And this is a place where Desmos is going to shine. Right? You can just type it in exactly like you see it, turn off f with one click, and say, okay, on the interval 0 to pi, 0 less than x less than pi. I'm just assuming we're not going to have a 0 right at the endpoints, and it looks like we're not. 1.54 and 2.47. I'm just going to leave those on screen. There we go. I'm seeing those answer choices. I'm selecting them. I'm moving on. A large wheel of radius 2 feet is rotated at a constant rate. The figure provides a representation of the wheel. Okay, we got a start point. Time t equals 20 minutes. 120 rotations of the wheel have been completed. Right. The period is going to be like the amount of time it takes to complete one cycle. So it's like minutes per rotation. And so that's going to be 20 minutes divided by 120 rotations. So the period is going to be 1 over 6. Okay, and we're also going to say period is equal to 2 pi over b. I am noticing right now that I've got 4 different values of b in my 4 different answer choices, so I'm going to use that. 1 over 6 equals 2 pi over b. Okay, so I'm going to multiply both sides by b. Okay, multiply both sides. I can do that one mentally. That's going to give me 12 pi, and so that will be answer choice D. Oh, end of section 1. I'm here at the third page, 31, 32. Oh, and then we had answers all along. I didn't even realize that. Could have been checking my answer on that one that I was unsure about with the order of the transforms. All right, so that's going to be all for this video. It's probably going to be my last AP Pre-Cal video for a while, but I hope it was helpful. Thanks for watching.